Remove duplicates from sorted list 2. Given the head of a sorted list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. Okay, so in example 1, given 1, 2, 3, 3, 4, 4, 5, we end up with 1, 2, 5 because as you can see there's 2 3s and there's 2 4s, and if there's basically any duplicate nodes, you want to get rid of all of those nodes. It's not like remove duplicates from sorted list 1 where you keep one iteration of each node. If there's duplicates, you just completely get rid of them, right? So all 3s and all the 4s are gone, and that's why we have 1, 2, 5. So I guess now let's walk through the algorithm that I would use to solve this, right? It's just pretty simple. So basically what you could do, right? Unlike if you wanted to remove every node except for the main node, for example 3, right? You get to 3 and then you realize 3 has a duplicate because it's a sorted linked list, so if 3 had duplicate it would just be right after it, right? So you get to a 3 and you check and be like, oh yeah, there's a duplicate. You could pretty much just from that node you could route its pointer to the node to 2 nodes away from it, right? So skip over the 3 and go straight to the 4, and now that node's gone, you've deleted that node. But we can't do that with this problem because we want to get rid of the node itself, so we'd have to have a previous pointer. So what we could do is we could add a dummy node and we could have the previous pointer at that dummy node, and then we could have a current node starting at head. Here's how we could do this, okay? So what we could do is at first we could have a while loop that checks to see if the current node that we're at has the same value as the next node after it, okay? So yeah, if the current node has the same value as next node after it, then we know that there's a duplicate, so we can move that current node up, and we keep doing that until we find that the node that comes after the current node is different, at which point we would stop. Now what we could do is previous, right? So previous would be at the beginning. So for example, right, let's take 3 here because there's actually duplicates there. So if previous is at 3 and cur's at 3, we keep moving cur up until we get to the second 3, and now we see a 4, so we leave cur there. Now what we could do is we could pretty much just previous would be at 2 and then cur would be at 3. Okay, and then we'd keep moving cur up. And then so what we could do is we could route the pointer from 2 all the way to 4, and then all those 3s would be gone. So yeah, a previous and a cur, and so yeah, so pretty much what we do is we'd keep doing that. We'd use that approach where we cur pretty much goes over all of the nodes that have the same value and covers those. So then we could we just choose the node right after cur and then get rid of all of those duplicate nodes. And previous pretty much just keeps track of the start or one node before where the duplicates start, right? So for example, in example 1, right, let's go through this algorithm. So previous would start at dummy, which comes before 1, and head would start at 1. So at head, we check to see what's next. Oh, it's a 2. A 2 is different. So basically, what we can do is we can add an if condition after the while loop to see if previous dot next is equal to cur, and I'm not talking about values, just the node itself. If previous dot next is equal to cur, that means there was no duplicate because cur never moved. So if that's the case, then we just move previous up 1, And cur would always move up one every iteration. So cur is going to move up one. And again, we do the same thing, right? So it's 2, 3. Okay, it's not the same thing. Cur's not going anywhere. Bam, we're going to move previous up one. Cur's going to move up one. Oh, but at this 3, we'll see that, okay, well, this 3 points to another 3. Well, now we want to move cur up one. Okay, cool. Okay, but now this 3 points to a 4. Okay, we're going to leave it there. However, this time, previous dot next is not equal to cur. So now what we're going to do is we're going to do the deletion process, which is where we point the previous, or we point whatever at node previous at, like that pointer, to one past cur. And we get rid of all those duplicate nodes. And then the process continues. Okay, now to like code it, right? Okay, so if I were to do this, I guess okay, I guess we could start off by creating the dummy pointer. So dummy is equal to list node none, and then dummy.next would be equal to head, right? And we'll do previous equal dummy because I don't really want to move dummy. We'll just call it previous, and then cur is going to be equal to head. It's hot. Games. Been working out. Alright. Okay, cool. So this entire loop's, by the way, this entire loop's gonna run until cur reaches the end. So while cur and cur dot next, while cur and then cur dot next, we're gonna do is while cur dot val is equal to cur dot next dot val. We're pretty much just gonna be cur dot next. Yeah. We just want to move cur up one, right? That's the first thing we're gonna check. But okay, but if that's, then we're gonna see. After that, what we want to do after the movement, we want to see like, oh, did it really move? If it didn't move at all, so if the value wasn't, didn't find any duplicates after it, if there weren't equal values, then, there's no duplicates, right? The way we can check that is if previous dot next is if previous dot next is equal to cur, yeah. If previous dot next is equal to cur, what we're gonna do is previous is equal to previous dot next, and we're gonna do is, okay, so when would we want to actually do the deletion, right? Let's think about that. So we wouldn't want to do any deletion unless we actually like found a duplicate. So we'd have to make sure it's a duplicate, right? We actually are deleting duplicates. I guess let's see. Okay, let's just start at the beginning, and I'll see how I can do it, right? So while the current value is equal to the value of the next node, cur is going to move up. Okay. So like here, for example, we're going to see that cur doesn't move up. And since cur is not moving up at all here, I don't want to like delete anything. Shit. It's kind of tough. Okay, I guess if previous.next is equal to cur after doing this, then we move previous up. Otherwise, we would do the only other option is to actually do the deletion, right? Otherwise, we do previous.next is equal to cur.next, right? Yeah. Previous.next would point to cur.next. And cur is going to be equal to cur.next regardless. And you could just return like dummy.next at the end. Because that was preserved. Okay, so none type has no attribute val. So while cur.val is equal to cur.next.val, cur is head here. While cur and cur.next. While cur.next end. And it's just while cur. While cur is not none. And then while cur.next is not none. Okay, yeah, that was it. Okay, so the runtime complexity of this would be O of n, because cur is looping through the entire linked list. This while here, the while loop instead of the while loop, while cur dot next, and so. Okay, so in a worst case scenario, like let's say we have, you know, a linked list with just all tens, that would loop through I guess that could loop through everything. Okay, let's figure this out. Let's figure out, because I did get this from another solution, so it's O of n. Why is it O of n though? Okay, it doesn't restart from the beginning each time. Okay. Oh, wait. Yeah. Okay, in a worst case scenario where the inner loop is going to traverse through the entire array, the outer loop is only going to have one iteration, right? Because think about it. If it's all tens, only one can run at a time. Yeah, if it's all tens, then cur would just reach the end, right? Like all this cur dot next, it would just reach the end. That would be it. So it is O of n. And the extra space is O of 1 because we're not creating any new structures relative to the input.